Hello everyone. So today I am going to talk about the art of statistical flows in web application. So what means logical flow? So these flows are related to the logic in which the server operates, and it is in fact wrong logic, meaning that the server works in the wrong way, and somehow we can explain the wrong way in which the service operates to achieve a malicious goal. And from this, you cannot perform tests to detect the types of flow if you do not know how the application works. So also, it is never possible for a non-variability scanning tool to detect this flaw, or because they are designed to work in an automatic way that does not know the logic in which the application works. And from this, there is a very wide difference between the technical variabilities like SQL injection, cross-site scripting, and other bugs, and the logical variabilities. So there is very wide difference between the technical variabilities and the logical variabilities. So therefore, the logical flow is really a complex problem and not made the corporate and the researchers in information security sector, because it is depends on a very exciting and philosophical way of thinking. So you need to think outside the box if you need to detect that. And it is open for some professional hackers. So this talk is divided into two parts. So the part one contains the classic logical flaws like parameter tampering, manipulation, or manipulation, sorry, undercount recover, and two-factor authentication bypass and privilege escalation. So we will conduct memory experimental tests in labs to begin creating complexity without which we can detect and study this stuff from scratch. And we have the part two, and it contains the unknown reward logical flow that we have already discovered on background programs with addressing part of concept exploitation videos. So I want to thank this guy, Usama Sahun and Rick Masuri and Timmy Cosmery, Dylan Landro for supporting me. They are amazing and they are supporting me in all days. So who am I? I am Sheikh Laban Masoud, 26 years old, a security researcher and background hunter. I am very interested in background technology, programming, development, and expert development, and discovering websites and software availabilities. I have had until all of this year started my discovery of more than 15 zero-day exploits. So, and I was ranked in 2018 by Microsoft among the top 100 security researchers in the world, and I was indeed a Black Hat USA. I have been worked in this field of security since 2009 and 2010 for several famous security companies like as Microsoft, Google, Apple, Facebook, Dell, Huawei. So I have found a lot of bugs in their systems and in their websites, and they fix all my bugs. So I am a apprentice tester, and I have been I have experience in doing the exploitation as well as working direct in the information security sector, web services sector, and the concept security area. So all researchers know me that I did not come from a high background. I never studied computer science or information security or anything at school. So we have several things that we talk about in this outline. So we have what is the logical flow and why logical flow, and the root cause of logical flows, the top 10 business logical attack vectors, and other types of logical flow that we have already discovered them in the boundaries. And what is the impact of the logical abilities, and what is the difference between the technical variabilities and the logical variabilities. So as I told you previously that you cannot perform tests probably to detect critical flaws if you don't know how the RTO work. So it is an amazing way of thinking. So it's good. So what is the logical flow? So sadly, as the phase of web development has evolved and has become more complex. So this has led to the development and the specification of logical flows attacks that leads to exploit the wrong way in which the app works. So the logical flows are designed and implementation flow of an application that allow an attacker to manipulate an application logic. And is also an issue where the app does not work as expected from a specific condition. So when we talk about business logic, it is a set of rules that are set by developers like us, infrastructure, permissions, privilege, and how to buy and pay prices and those things. But this rules does not necessarily have to be in a commercial activity. So we can say that this logical flows that we can call is also application logic flows in other sectors. So why logical flow? You cannot use automated scanning tools to detect you, and you need to think outside the box. And there is a lot of developers don't even pay attention to it, and it may cause severe damage in the business compared to the most web application flows. So we have classical flows with, for example, parameter template or parameter manipulation attack, account takeover, two-factor authentication bypass, and query escalation. So our first example is about the parameter template attack. So the parameter template attack, or also we can call it parameter manipulation attack. So it is based on playing with the application parameters that are exchanged between the attacker and the server to achieve a malicious goal. So this logic flow is led to detection in the business by changing the price of an item from 1,000 to $1. And for negative pounds, you can buy lots of things just with a few cents and gain the price access. So the parameter template can be often be done with four things. First thing is the URL to the string. So if you need to understand the URL to string, you need to understand what is the query parameters and what mean the query strings. So the query parameters are a defined set of parameters attached to the end of the URL, and they are extensions of the URL that are used to help define specific content or actions based on the data being passed. And the query string it allows you to pass information to and from a website by simply editing or appending that information to the end of URL. So this information is stored in the query string and is captured by the website when it's reached the URL. So we have also the form fields. So the form fields, or we can call it also a form body. So it contains tailored elements that define how each element of the page appears and behaves. And we have also the third thing is about the HTTP header. So the HTTP header lets the client and the server pass additional information with an HTTP request and with an HTTP request or response. So when you visit the website, your browser sends a request to the web server to get our information from it, and the server in the server response, some information is exchanged in additional to the actual data. So We have also cookie is an HTTP request header used the request is sent by the user to the server. So it contains it contains the cookie previously sent by the server using set cookie header. So it is tiny pieces of data that are that it can store in the user's browser, like tracking, personalization, and there are most important things like authentication. So all these are the most common use cases for cookie. So cookie have a lot of privacy concerns. So we have two store websites. So these websites are variable to parameter manipulation attack. So in this example, we see that there are two websites with different values in the parameter. So we have a store, the com and this is the file, and we have the user ID parameter with its value. And the second website is same with default IP file and user ID parameter and the value. So as you can see that these values are not the same because it's about the user. It's about the theme. It's about the user account. So it's different. So an attacker can so in this case an attacker can change the parameters in the area to gain a reverse access. So we have an example one about the parameter attack. So if you want to buy a laptop and you see in the area like this value, so order ISP, and you have HMIP parameter with its value 1 and the price parameter with its value 100. So when we see this value, so we find that there is two variable parameters, HMIP, and we can manipulate it, and the price parameter also we can manipulate it. So if you make some changes in the price, and we send we send our request. So for example, we send the price of the agent from 100 to 1, and we send our request. So we see that we buy a laptop for $1, even though it costs 100. So our example 2 also is about parameter template attack. So if you want to buy a jacket with a price 1,300, so if you accept the request of the jacket price, so we see that there is interesting things below. So we find protect ID with its value 1, the retire parameter with the protect values. So we have also the quantity 1 and the price of this jacket. So so the request method for this request, the request method for is post, and the parameter and the parameters, the protect ID is the ID of the project, and the retire the direction of the project, and the quantity, how much quantity you want to buy, and the price of the project. So as you can see, the price on the game when it comes to the quantity size, it's like when it turns the quantity from 1 to 2. So the price will change. So let us study the values of our parameters. So as you can see, the protect ID is value 1, the retire. It means that when you buy the protect, so will be resurrected to the protect again. This means that you already buy it. So and the quantity with its value and the price of gold. So let us see the values of currencies. So let's think a little bit. The protect ID, there is no need to count this identity for the protect that you want to buy, and the buyer is it's like a response from the server, because when you buy this jacket, so you will get a response from the server, from the buyer that is to the queue to the protect again. This means that you don't this you buy the jacket. You have the quantity. So I just to you that you can manipulate size and the quantity size and the price. Also we can manipulate it size and we can also transfer price size. So as you can see, your star balance is 100, and you want to buy a jacket for 1,300. So it is reasonable to purchase it when you start to do this enough. So as you can see, like the price is high from it's very high. It is 100, 1,300. So on this start to do is 100. So I think it is not reasonable to purchase it. So let's do something. So when we intercept the request of our product, and we do some changes in the price. So it's like if we change the parameter value from 1,000 to 100 and send our request. So what's happened? So we buy the jacket with 2 cents. As you can see, because we change the price of the item from 1,000 to 1, and then we got that we buy this jacket to buy for 2 cents. So let us buy 2 pieces at the price of only 2 cents. So first we need to change the quantity size and make the price 1. So in this example, we added value 2 quantity. This means that we want to buy 2 jackets with a few cents. As you can see, the price is still 1. Price 1. So what happened? So we succeed to buy two jackets with a few cents. So as you can see from the structure. So let's do something into this. So let's doing this in our lab. So parameter manipulation. So we use this lab. So from Postgres gives a lot of many things about cryptography and cryptography. So from this lab we will show you how to exploit parameter manipulation variability. So we need to, as you can see, so you can exploit logical flow and protect workflow to buy things for set price. So from this lab we need to exploit parameter manipulation variability to buy a jacket with a low price, unit cost, high price. So firstly we need to access to our account with our credentials, winner and Peter. Winner is our name and Peter our password. So let's access to our lab. So as you can see here, we like to shop. So we need to buy this jacket. This jacket is price 1,300. So to buy the details, firstly we need to look into our account. So have winner username and our password is Peter. So there's jacket that we want to buy. Here is the fact that we need to do something. So this got the about. So quantity means value. So one is means that how much you want to buy. So we edit one. So let's make it one and try to enter car. So we need to go to, so as you can see, our stock credit is 100. So we need to go to our card and we see that the price. So we cannot, as you can see that it's also, you cannot buy the jacket with our low stock credit. So we need to move our agent. So let's see. So as you can see, your card is empty. So that's the rule. And try to intersect anything for this case. So we need to access this request, edit the card, and we see that there is 4 parameters. The product ID 1 and the buyer for the product, and the quantity is 1 and the price is the price of the product is 1,000. So, but what if we change the price value? So let's make one and try to send our request. So let's see what happens now. Go to our card. So as you can see that we change the real price of the jacket. So when we edit one value with the price parameter, so you can see that the price was changed to a few cents. So as you can see that the figures are changed by cost. So let's order and see that if we can so we can see here we successfully buying this jacket with a low price. So by exporting or logical flow inside this shopping website. So but what if we buy 5 jacket with the same price, our low price, 2 cents. So as you can see that the tutorial of 2 cents. So let's go back home and we try to edit a 5. The quantity. So let's insert our request, edit the card, and as you can see that the quantity is 5 and the price we need to complete, so to 1. So let's find our request, see what happened. So we see that there is things how So we buy 5 jackets with our same low price. So let's place order. And of course, we successfully buying 5 jackets. Second example, we have account takeover to factor bypass process. So there is a lot of two-factor bypass vulnerability that leads to account takeover. So what means account takeover? So it's a type of identity theft. For example, you are user number 1 and you have taken over access to account of the user 2 and you have actively used the identity. So what it means two-factor authentication. So in the case of the second authentication, the user must identify himself and prove that he is the owner of this original account, after skipping the first step of authentication. So after logging into your account, two-factor authentication is used as a second form of authentication, like text message containing a code that you receive by phone or email, your fingerprint or your fingerprint or facial recognition. So two-factor authentication was established as a form of protection. So if you are a victim of phishing attacks and your account has been stolen, so the attacker will not allow access to your data despite having the password. But sadly, the second step, authentication flows leads to takeover of this account access completely. So if you ask it to enter a username and then a password, and then the servers asks you to enter your verification code, then you are now in the first verification step, which is that you have entered your username and password. It means that you do that logged in only. But the second verification step is to enter the verification code that was sent to you from the servers to your phone or your email in order to access your account. So sadly, many services does not verify if you are under the verification code or not, because it's a complicated step. So when the second verification step is completed, the servers will redirect you to your account, your profile, for example, and for example, you see in the URL this thing, my account with an ID and username. So how to test if there is a bypass inside or not? But firstly, you should log in again to the servers to think your credentials, and then and when you are required to complete the second verification step, you need to put in the URL just for test that thing. So you can see that we have open up the website.com and my account ID and username. So not all services have the same thing because you can see that there is, for example, my profile or your username only. So, and to research, you will find that you have like factor authentication because the servers does not verify whether or not you are under the protection code. It is never verify this authentication step. So, and you have a lab. So, as you can see that this is a lab for resolving the applications and device. So, as you can see here also, this is lab, this labs to have authentication computer class. So we have already authenticated this as well, but we don't have to the response. So to solve the lab access covers my account page. So we have the session and the so for example, covers is a victim of phishing attack, and the attacker stolen his credentials. As you can see, the username covers and the password Montoya. So when he wants to access the account. So we see that there is a two-factor authentication inside. So, but how to skip this? So let's go to our lab and doing and show you how to exploit this sample two-factor bypass. So we have Carlos and Montoya. So we need to access the lab now. So I this is login. So we need to look at our account and we edit Carlos username and the password Montoya. So we find our account. So we find that there is. So you need to enter for the script code. So let's see if we got an email. We got the verification code. So it's missing the index and the key. So you need to do okay. That's the problem. So what we're gonna do right now is to edit the thing. For example, my account. Carlos. And you need to access. So as you can see, we are successfully access the Carlos account takeover about the two-factor verification. So one of the most dangerous attacks that allows an attacker to report the verification code, and this will help him hack any account on specific servers once he knows the username of the victim without the need to know his password. So here we have two requests. But firstly, the attacker locates entry the account and runs through the first step of verification. So as you can see from the first request that there is a username and the password of the attacker. But in the second request, the server has assigned a cookie in this request. So as you can see, but we found something interesting in the verify parameter with an attacker value. So the attacker discovered that the username account was being authenticated by the cookie. As you can see, as I said previously, that there is a verify parameter, but in other words, that the verify parameter and the attacker value is about the name of the user who will access to his account or he want to access to his account. So, and after that, the server asks the attacker to authenticate in the second step. So as you can see, there is a verification code that was signed by the attacker. But as you can see that the attacker, as you can see that from this picture, that the attacker tried to intercept this request and change his username with the username of the victim and trying to break the verification code. So the attacker will change the username of his account with the name of the victim users, and then he will launch a brute force attack on the verification code of the victim. So the service does not, so there is most services that does not use rate limits to verify, but of course, and this feature can be bypassed also. So as you see that pre-processing the verification code on the victim's username would allow the attacker to be able to access user's account, but only the username without having to know the password. So as you can see from this picture, that the attacker has successfully pre-processing the username, the victim user, the victim confirmation code. So now we have a great proof of concept here about this. So there is a video that showing how to do this. So sorry, I can't access that because there is something. So I think that post trigger try to fixing or editing some features in the lab. So I try to show you a video how to do this. So how an attacker try to brute force the victim's confirmation code in order to access to their account. So as you can see, firstly, there is the access to his account. We want to access to his account with a winner username and Twitter password. And I can find me in that. Then you accept the request, and you see that there is a verify parameter with a winner parameter. So we try to send a request, and then we try to send the request to the Twitter, and then to change his name with victim Carlos, username, and then you see that we need to enter the verification code. So in this step, so we try to look again to his account, I think. No. So he got the content, he tried some text. So the verification code for his account now, winner. So he tries looking again with winner, username and password Peter, and then he put a wrong verification code in order to do a brute force. So then there is a request. So he tries to send the intruder, and then he changed the username of the account with a coward victim. So and then he tries to edit code, and then he will try to password. So as you can see, number one numbers, and then the 100 from 2. Okay, so he try now to pass the code. And finally, he found 302 request response from the server. So then we will try to access. So he do show response. He will show the request response in the browser, and then we try to copy, and then it successfully access to the covered account. So let's go now to privilege escalation. So when the normal user does not have permission to access certain information or sections that are not available to him, so he is not allowed to access them. But if there is a glitch in the server that allows the normal user to escalate that privilege to administrator or super user by verifying the permissions that does not allow him access, so he is allowed himself to access them. So as you can see, there is a super user and there is user one, but the super user has privilege, edit, delete, create, read privilege, and the user one needs a permission or read only. So the user one has found a logical flow in the servers in order to get access to the secured resources. But as you can see, the parameter template attack also can do that. So there is user role control. So there is an admin with control and user one with control. So the attacker will play with this parameter in order to get authorized access. So as you can see that some services has used or user role for example Carlos, and there is a user role, for example admin, or user role for example user. So an attacker will change his user role in the URL to admin, and then he got unauthorized access. So as you can see, user role also can be modified. As you can see from the first request that the attacker has sent a request, and then he finds that he is role one. So role one is about the users that have a few permissions, not high permission to access to the security sources. So in the request 2, the attacker has tried to edit role ID 2. So the role ID 1 is for, as I said before, that the role user 1, the role ID 1 is about the users that they do not have a very high permission, but the user role ID 2 is about the administrators in that server. So in that server. So in the second request, the attacker tries to edit role ID 2 in the JSON in the request file. So he sends the request then, and he got a response that he is role 2 now. So firstly, the user account with role ID 1 have that's my account and room and then logout. So they just access to their account only. But when he changes his role, so he is access to unauthorized function. So as you can see, admin panel. So he access to the admin panel page. So let's do that. So we have now our lab. The user role can be used in the user software. So this lab has an admin panel at admin. So it is only successful to log in users with role ID 2. So the role ID 2 for just admin. So to solve this type, I think to delete user Carlos. So you can look for it. So we need to log into our account with a winner and a Peter. So credentials. So winner. So we need to access our lab now. And then, as you can see, you try to log in. And then you choose a winner and the password Peter. So you need to, as you can see, that there is a logout my account room. So as you can see that if you need to update your mail, you need to, so I need to put another email, for example, so I need to edit this, for example, or hacker, yeah. So I need to send this request now, and then we found that there is some sensitive information there. So we need to go to the feature, and then you try to go to the feature, and then we will see what happens. So as you can see that there is in the response, there is a role ID 1. So we need to do some changes there. So of course, as you can see conclusively that we need to access to the role ID. So to the role ID 2. So as you can see, we need to go there. So is to write ID. So we need to do this. Score. So what we have to do now is to write ID 1. ID 2. Then we try to find the server error that we need to get. So as you can see from the request, this, that, then so we have our ID 2. You can see. So we need to request. And as you can see that we have access to the admin panel. So as you can see underneath, so there is users and administrator, and there is the security, and I put myself in the security case. So I have escalate my privilege to the normal user, from the normal user to the super user. So I need to delete this, and then we kick off the slash. So, and now we have a real world example for privilege escalation, reset password, and it allows to hack the admin account. So, most services running a repository CMS to build API. So, we try to we find this vulnerability in background program. So we send a request to the server, and then we got that this server is running Sprite version 3 to build an API. So let's see it. So and then we did some research, and we found that we found that there is a CDA in that version of Circle in the feedback. So as you can see that there is a problem in the password reset in the auth.js file, in the admin package, and in the user's permission also. So and then we find the exploitation code for this vulnerability, but we can't do anything with it. So we need to do this manually. So as you can see that there is a mistake made by one of the software developer, and I think he copied and pasted the same ODS file right to the admin and put every user permission without counting them, to the point that users can access to the admin account by resetting his password. So as you can see, I think that the user has, after developing the first auth.js file in the Turkey admin path, he copy paste the same ODS without putting it in the user's permission controller. So we have collected lots of information about our servers. Like the first part is about the register as the first part is about register as a normal user. So the normal users can try to create an account through this first part. So in the second part, we see that the forget password, but this part is about reset passwords for normal users, but the third part is about the reset password for admin. So firstly, we create an account by sending a post request to the first part, register with the following body. As you can see that we have username and email, and we put our password. And then after creating our account, and then we try to forget password to see what happened. So we send a post request to the second part contains this following body, email, and the URL. But in the URL we found our second part. So this API of forget password, we found it in the URL. So we changed that URL with the third URL for resetting password for admin. And then we send a request. And then we receive an email for resetting an admin password. So in this case, we know that we are in the right way, but we're not be able to do anything with it because it's nothing for us. And then we got a request from the server. It's about to edit a new password for the admin. So we edit the password hacked and we confirm our password to hacked. And then we send our request. And then we receive an admin token as well in the affirmation of the system admin in the response. So as you can see that the admin token and we got a username for the administrator is admin. And then we log into the app using the password hacked and the username is admin. So start to post request to the admin of the. So as you can see, we hacked the admin account using the recent passwords. So and then we have an outline. So root causes for root causes of logical flaws. So there is a root cause of logical flaws post design, for example, and the developer uses technology that he did not study or understand. So we have previously raised in previous installation about the developers at an example website using an open source CMS CyberWeek API that he did not study well, and he entered onto his site, which led to his account getting hacked. And there is also a lot of manual attacks. So a lot of companies on researchers tell that automatic scanning tools will be fast and we will find vulnerabilities easily with fast. So in this case, that you can find some of technical vulnerabilities, but you cannot find logical vulnerabilities. So I prefer manual testing and scanning. So of course it will be slow, but it will be a way to find logical vulnerabilities also with the technical vulnerabilities. So we have the top 10 business logic attack vector here. So you can, if you use a lot of automated testing tools, so you need to study them well with how they work, and we can discover that they do not work in this case. Therefore, it is very necessary to do a manual test to discover the security risks that enable attackers to manipulate business logic. So as you can see, there is the top 10 business logic attack vector. So all researchers should to understand and understand them and study well. So this is a high top 10 logical flaws. So, and then we have another type of logical flaw. So it is we find it on Facebook. So as you can see, unknown pitfall of logical flaw is present on Facebook. So when the attacker creates an account with this information that is not owned or is not really exist, like an email or phone number, so Facebook will ask him in the second authentication step to see to put his correct information to verify his identity. So in this case, the attacker can create fake account with information he does not own by exploiting a logical flaw inside the second authentication step to verify this information. So the program are related to how Facebook works. So as you can see here, how does Facebook do it? So as you can see from this two picture that our number that our force number, our wrong number that we put in Facebook. So Facebook has tried to tell us that this number isn't working. So we need to edit our real phone number. So and then we tell you Facebook that they have sent this code to the phone number, but in reality it is not your number. So so Facebook gives you some choice. As you can see that you need to confirm by email or edit phone number or sign the code again. So we have done everything, but we discover that in normal case, we are not allowed to go beyond the second authentication step. So we cannot skip the permission that we have after Facebook verify that our information is correct. So we try to intercept all of this, all the requests of the second authentication step in order to find something interesting so we can skip this. But we can do anything. So let us think logic. So we have to study the way Facebook works. So which is the way request and the response works. So how does Facebook study the requests that are sent by the user, of course? So let us think briefly logic. So if there is a wrong request included, it's not building a picture or sending message. So Facebook will deal with it that there was a problem with this request or has something wrong, and it will ask you to inform them of that. As you can see, you will get an alert from Facebook that there was a problem with this request, and Facebook will force you to contact them about this form. So, however, so if you completed the first step of certification and there is a problem with a specific request, so this will occur to you, as I told you previously, that Facebook will alert you that there is a problem with this request, and they want from you, and they will ask you to report a problem on the condition that you must complete the first step of certification, meaning that you have already logged into your account. So, but if a problem occurs when completing the first step of certification and you are unable to access your data, like your profile, and you want to inform Facebook about that, as you can see, so you need to click on the report problem, and you will see that form that you should contact Facebook about your problem. Okay, so, but we find something interesting in this. We find that in the approve, as you can see, there is a home, edit profile, message notification, chat, and everything. And this means that my account was accepted when I enter into the report of problem. So the report of problem form allows me to access my account. But we are still in this. But we are still have to skip the second step of the authentication. So how we will skip this second step of authentication and we open our account? So with information that does not own. So I got an idea that what if we can create a request issue within the second step of authentication, even though Facebook does not allow us. So I think it is an evil and a genius way of thinking. So, but how we will do it? We have read our request within the second step of authentication within our account Y. So our account Y that we want to open it. So we want to keep the second step authentication to open our account Y. So we cannot withdraw a request from a third party because Facebook works in a way that the process must be done from within Facebook to create a request issue. Meaning that we need a request related to Facebook. So, and then we created an account X that also needed to skip the second step of authentication because we created it using information that we do not own. And then we can play with all requests inside the Y and the X account. So let's focus on we can play with all requests inside the Y and X account. But I need to open my account Y. But what if we anchored a request from an account X to account Y? So what would happen to Y account? So we try to intercept a request from the account X, and we try to save it on our desktop, and then we open our account Y, and then we intercept a request inside the Y account. So, and then we make some changes. It's like we are putting the X request that is from the account X inside the account Y account, and then we send our request, and then we find that Facebook log out our account and redirect us to log in again to Y. So when we try to log in, so when we try to log in, so as you can see that the request Y that we send or request to the Facebook server that we are on account Y, but in the same moment, the Facebook will execute the account X. So what will happen? So Facebook will direct us to login. So we will click on the account Y to log into it. So here the account X request is a fake request not related to the Y account. So Facebook will execute it and Facebook will implement it as the basis that it requested X. But we want to enter again to our account Y, and here will appear to us a request issue, and to talk with the attacker will go to the info verification and open the account. So as you can see, firstly from the first screenshot that we intercept a request from the account Y, and we are this means that we are inside our account Y, and we copy paste a request from the account X and we put it inside the account Y, and then we send our request to the Facebook server. So in the second picture, we find that Facebook will redirect us to log in again. So Facebook has log out our account and they tell us to log in again. But when sorry, there is something mistake here about account X, but I need to fix it. So in the first picture here, that account is about the account is correct. It's not. So as you can see from that picture, that Facebook direct us to login. So here is the account Y. And then if we try to login, Facebook will execute our account X request, and there it will appear to us the request issue, and from the request issue we go to the report a problem, and we will edit and we will open our account. So from the discovery we understand that the logic flows are related to the logic in which the application in which the server operates, which is in fact a wrong logic, meaning that the server works in the wrong way. And from this, we can expose the wrong way in which the servers operates to achieve our malicious code. So there is a video, there is a prop concept videos about this Facebook issue. So Harry, so I need to open it. So as you can see, firstly, we need to create an account. So we put an information that's not owned. That's not our information. So it is a wrong information. It's not read to us. So everything is wrong here. And then we open the account. And when we create this account, we find that Facebook will disable our account. So as you can see that it looks like this number isn't working. So we need to update our phone number. So we try everything here. We try to everything in the request in order to skip this case. So we try everything, and then We try everything. And then we will intersect a request. For example, it's confirmation, confirm with the mail request, and then we will replace it with an account request about the set phone number. So we create this request, and then Facebook will direct us to login again. So as you can see, and then we will try to log into our account again. We execute our request in order to see what happened, and then it appears to us our request is issued. So it's really amazing. But it's about you open an account from other account when the test account was disabled by Facebook. So and then we go to the report of problem, and then we open our account. So as you can see, we have successfully opened our account without verifying our information. So it is a really amazing bug. So it's really cool and great bug. So we have what is the impact of the logical flow. So from this thought, I think that a lot of people understand that logical flows is about stealing users' account by using their passwords or access to confidential information related to the user's account, and also privilege escalation is about to escalate from user to a super user or admin, and buying a lot of things with cheapest price and delete or change anything in user account. Skip the authentication, skip the second step of authentication, and also manipulate security. And what is the difference between the technical vulnerabilities and logical vulnerabilities? For example, how is SQL injection vulnerability detected? So to find out if the website is vulnerable to this vulnerability, the attacker will send an SQL command to the application database. For example, onto the malicious code to the variable parameter. So as you can see, we have a path, we have a file document PHP, and we have an ID document parameter, and then you can execute, you can send an SQL or malicious SQL commands in order to get access the database of that service. So, and then if you see an SQL error, you have an error in your SQL syntax, so the website is vulnerable to SQL injection. So this is what means technical vulnerability. So SQL injection and cross-site security and other paths are technical vulnerabilities. But how is a logic flow detected? So what if you were inside your bank account that was designed in a way that does not allow you to see other users' information, but to a logical flow, the bank allows you access users' account information by exploiting access control logical vulnerability. So it is never possible for any vulnerability scanning tool to discover this flows because it was designed in an automatic way, automatically preferably, that does not know the logic in which the application works. But let's say that that you can create a tool that detects a small number of logical vulnerability. For example, content management systems by checking the affected version because not all of its users will update. So thank you, guys, and I hope that I provided you with interesting information about logical flow. So let's move away a little bit on technical vulnerabilities and put all our focus on logical flows and work on reward programs as well and get lots of money. So let's make this world a safer space for everyone.